In this video, we'll take a look at sample exercise 6. We're told that a gas is at 25 degrees Celsius, so we're given a temperature. We may or may not need that for our calculations. We're also told here that we have a volume that is 1.05 times 10 to the third cubic centimeters. And then the container that the gas is in has a mass of 837.6 grams. And then when we evacuate or empty all the gas, we have a mass of that same container of 836.2 grams. So we want to know what is the density of our gas, and we're given that temperature again just to say that we want to know that density at that same temperature. So first we can remind ourselves rather, what equation do we use for density? Density is going to be mass divided by volume. So how do I find mass? Well, I'm given the mass of the container plus the gas. So we'll say container plus gas over here. If we subtract the mass of just that container, so this is just the container, right? We would end up with the mass of the gas. So if we did that, we would find that to be 1.4 grams. So I only have one decimal place in my final answer here because of the one decimal place in each of the values that I subtracted. So I have 1.4 grams for my mass. The volume, we're told, is 1.05 times 10 to the third cubic centimeters. So I can leave that volume as is, and then I'm going to plug in the 1.4 grams on top. So I'm going to end up with, after dividing, only two significant figures because of that numerator in my final answer. So 1.4 divided by 1.05 to the third power gives me 1.3 after rounding times 10 to the negative third grams per cubic centimeter. And that's the answer for sample exercise 6. Let's continue here with the final topic in this chapter, that is dimensional analysis. So when we perform what's called dimensional analysis, it's when we convert from one unit to another. So it's just a fancy way of saying we're going from grams to pounds or something like that. So dimensional analysis uses what are called conversion factors. So whether it's from one unit system to another, like the English system, to the metric system, like we see here, 1 inch equals 2.54 centimeters. Or we could have conversion factors within the same unit system, such that there's 1,000 grams and 1 kilogram. So again, we have different units, different systems, and the same system. We have conversion factors for both. And if we wanted to define this, we have these equal values or a fraction when we multiply or divide, we'll see, whose numerator and denominator. So numerator and denominator are the same equality or the same quantity expressed in different units. So same quantity in different units. And we'll see that we multiply by the unit that we want on top, and then we'll divide by the unit that we want to cancel out on the bottom. So we can say that we have our given unit times this fraction here, and we would cancel the given unit here by the unit that we want, or our desired unit. Right, so unit, unit, and then our desired unit on top. So these would cancel out. We would end up with our desired unit for our final answer. So let's take a look at sample exercise 7, and we can see an example of a conversion factor here. So we're given this equality. 1 pound is equal to 4.53.59 grams. And we're given a woman's mass as 115 pounds, and we want to know that mass in grams. So we can use this conversion factor here, and we can say we're given this unit, 115 pounds, and then we're going to set up this conversion factor where for every 1 pound that we cancel out here, we're going to multiply by 453.59 grams. And that will give us, after we round, let's see here, so we're given 3 sig figs here. I want to note that conversion factors do not affect the number of sig figs, since we know that this is really 1.00 pounds, right? They have an infinite amount of significance. So this one down here does not mean that I only have one significant figure. I can end up with 3. So at the end, after I calculate this, I would round to 5.22 times 10 to the 4th grams. And that shows us how to use a conversion factor, how to report it in the correct amount of significant figures, and how to round our answer. So let's take a look here at this next sample exercise, and we're going to convert here using another set of conversion factors. So we have our given value here of 515 meters per second. That is for the average speed of nitrogen molecules. We're given a temperature here, but again, just for reference. And we want to convert this speed to another unit, a derived unit of miles per hour. So we still do the same steps as we saw before when we're converting a single unit. Now we're going to convert both the numerator and the denominator. And we can use this equality here, this equation where 1.6093 kilometers is equal to 1 mile. Reminding ourselves that conversion factors do not affect our sig figs. So we can start with converting either the top or the bottom, and then our seconds here, to get to hours, we'll just divide by factor of 60 twice, right? Seconds to minutes, minutes to hours. So let's see what this would look like set up here. So I'm given this equality in kilometers, so I can set equal how many meters there are in 1 kilometer, so that's 1,000 to 1. And then now that I'm in kilometers, I want that to cancel, and I want to end up with miles on my numerator. So I would put 1.0 infinite amount of 0 miles on top, divided by 1.6093 on the denominator here. So now I'm in a unit of miles per second, but I want to get to miles per hour. So I can just continue here with adding on conversion factors. But now I want to cancel seconds out. So I want to say there are 60 seconds in 1 minute. And then I can say there are 60 minutes in 1 hour. So the seconds will cancel out. We can go back and cancel out our meters, our kilometers, and we end with miles. And now we'll cancel out these minutes. And we can go ahead and multiply 515 times 60 times 60 in our numerator, and then divide by 1,000, and then divide that by 1,000, I'm sorry, 1.6093. And your final answer here, if we were to round to 3 digits, because that's what we started with, that's our measured value, and conversion factors do not affect our final answer, we're going to end up with a value of 1.15 times 10 to the 3rd miles per hour. So 1.15 is your coefficient there. And we'll continue in the next video with the last sample exercise for this chapter.